All right, this is just a quick overview of the installation and how I plan it out. I brought over 2 circuits because I have to run all the way over to the other side of the barn. So if I'm going to do the work installing a cable, I'm going to bring 2 circuits over. And I drop one off here, the A13. I drop it down to here. That's all this is 1 circuit dedicated for the boiler. The other circuit jumps out, goes behind the wall, and we have it over there just as a convenience outlet on the wall. The circuit, before it goes down into this box, we have a surge suppressor on it. Because this boiler has expensive electronics in it, we want to clean the power up that goes in there with a surge suppressor. If there's any type of spike that goes in this line, it'll get absorbed in the surge protector. As long as this green light's lit, we know we're good. It's protecting the equipment. If this green light goes out, you just take this out, change it. It's a one-time use. So now the idea behind this is we have the whole boiler system running on this extension cord. This extension cord can handle about 15 amps safely. The whole boiler is only drawing 5 amps. So we're in good shape. The reason we have this is really twofold. If you want to service the boiler, this acts as a disconnect. You can just come over here, unplug it, and work safely on the whole boiler system without worrying about anything getting energized. And the other reason is if we do experience a power outage up here, we can unplug from the system, run an extension cord outside to a generator, and run the whole boiler system, keep the heat in here with the generator outside. Now all the power for the boiler is coming out of this box. We have the feed for the boiler. It gets wired hot. The other piece that gets wired hot is the makeup pump that's over there that gets fed with the transformer. That's a receptacle that's wired hot. That's the transformer that feeds it. And the only other thing that's coming out of this is the condensate pump. And I left this as a cord feed because, again, 2 reasons. Sometimes these condensate pumps, they burn out, they start smoking. You can just unplug it and you can make that thing safe. And if you want to change it, it's just a cord fed device and that changes it. So the other device on this is the circulator pump. This one is called the Takeo pump, but it's the circulator, and it gets controlled and fed from the boiler. So I wired it that way. Another way to do it is to put all of these wires in one splice box, but the disadvantage to that, it might be more convenient to wire it that way, but whoever comes after me to work on this would have to take the cover off, trace out all the wires, and try to understand what I did. If I wire it this way, he could see, just by looking at it, how it's fed. It's a simpler install. The only other cable that's on this is a low voltage cable, and this is for the outdoor temperature sensor. We encased it in MC, or armored cable, because it goes to the wall, it goes into the insulation, and with a barn you always have to be mindful of mice, rodents, insects, so this protects it when it goes on the wall. So follow along for the details of this installation. All right, today's job is we're going to wire up this boiler, and I always find the easiest thing to do is let them install, and then when everything's laid out, then that's the time that I come back and wire it up. It's a gas-fired boiler, it's liquid propane. The only electricity that this thing draws is enough to run the brain inside of it and the blower. So right now we're going to take some readings. The boiler is running because the boiler installer wired it up temporarily. So before I wire this up and decide what amperage I'm going to need out here or what size wire I have to run, I'll do an amperage reading. This is a south wire tester, multi-tester, works with Bluetooth. It'll report right to my phone if I needed to, but let me take some readings here. This is the main feed coming in, and it's drawing 1.2 amps. That's for this whole boiler. Then we have, this is the pump, the circulator pump, and that's drawing 0.6. So the 2 of them together is less than 2 amps. And the only other thing we have drawing here is, this is the condensate pump that's around the back of it. And it's not reading anything right now because it's not running. So I'll take a look at the nameplate on that and see what it should draw. But all in all, it only draws about 3 amps. Less than 5 amps for the whole system. With that, I know I can just run a 20 amp circuit is no problem. So that's what we're going to do. I just wanted to show you the condensate pump that's in here. Let's see if I zoom in on that, you can see the nameplate. Any electrical device has to have a nameplate on it. It says 115 volts right there, and 1 amp. Shows 1 amp. Okay, so now I have the amperage that's required to run the system. The only other thing is some auxiliary, very low amperage draws, which this is going to be a transformer that it needs to get plugged in. It's 120 up to 240. We're going to run it at 120, 1.3 amps. It does draw a little bit, but nothing to really be concerned about. So this is why I say we're still under 5 amps on the whole system. So what I decided to do to feed this is I ran a piece of BX. The panel is all the way on the far end of the building, so I had to run BX up on the wall. It's actually MC cable. Ran that up there, brought it in here, and then I ran it behind the wooden board, and it's coming out here. I'm going to run one circuit for the boiler, the black circuit, and then I'm going to run the red circuit just to have a spare circuit down on this end. And we're going to share the neutral. The plan I came up with is to put a box here, a main box. This is where I'm going to drop off one circuit, and then I'm going to bring all the power that is necessary for the boiler into a box right here, and then I'll feed this boiler with one feed. I'll feed this condensate pump into the steady feed on the wall, and then the only other thing really required is, it's called a TACO pump, the circulator pump. It's over there. That I'm going to feed off the boiler just the way it's wired here. This is coming off the back of the boiler. That's the feed for the TACO pump, and that's just temporarily wired right now. I'm going to make that look a little nicer, and because that's fed off the boiler, I'm going to run my cable the same way. I'm going to run it with some MC cable, come down in here, go through that opening, and come up into one of these holes. And that's what's going to act as the strain relief, and then it just gets terminated. It's terminated right in here. This is not tied into the panel yet, so I know that it's safe to work on. And then I just determine what looks best on the box. This tends to be a better connection to go into because it can't break out. This one can, but it's acceptable to use that. That's fine. But I'm going to use this to cover up this bit of blowout. I just want to shorten this a little bit. As soon as it free spins, it's good. It's important to get these red heads in. I'm bringing it in a little closer. And that's to take this sharp edge off of this point right here. That can dig into your wire sometime and cause a short. So take the nut off, lock nut. And I'm going to leave this sideways because it'll line up with the slot that I have here. Make sure you get it all the way up in as far as it'll go. You can see the red head inside. I don't know if you can see that on the camera, but you can see the red head sticking in. For most terminations with the electrical, you want to just make sure it's a good mechanical ground and a good electrical ground. You go snug, you take all the play out of it, and then just another little bit more than snug is usually the trick. That covers up most of that little mess. Check it. So here you can see we're wiring up the receptacle that's going to feed all the equipment for the main boiler. I'm leaving the box above as a splice box. I could have put the receptacle in up top, but that just would have made it very crowded. So I'm leaving that box up top just as a splice box because there's enough wires in it already. We're wiring up the surge suppressor. And that surge suppressor is only going to control the circuit that's feeding the boiler. That's why I put that surge suppressor at that location. It's also very easy to see. When that surge suppressor is on, there's a green light that says it's in good condition. So that's a convenient place for it to be so that you can see the light at all times. And then when you're making your connections, you always do your ground wires first, then you do your neutrals, the white wires, then you do your black wires. But you'll see all my wires are the same length. They're all at a comfortable length to work on. You can pull them out of the box and splice, but they're not too long where they're going to be hard to pack in the box afterwards. And you'll see in a second when it's all spliced. There's a reason why I make everything nice and neat, and that's really because if something's wired neatly, you can usually tell that it's wired correctly because somebody took the time to make it neat. It's also, anybody who follows me and opens up this box and looks at it will see at a glance how it was wired and what I was thinking when I wired it. It just makes a lot of sense to the next person. Now we're wiring up the splice box that's going to contain the wires that are both wired hot and the receptacle that's going to feed the condensate pump. Making sure everything's nice and neat. We want it to be visually pleasing, but also when it's laid out correctly like this and there's a nice flow to the wires, anybody looking at this can make sense of it very quickly, as opposed to all the wires just being crossing each other and being different lengths. So we're just going to wire one receptacle into this. My neutrals, my grounds are done already. I pre-wired the cover with the receptacle. You're splicing those wires together. You don't have to twist them too tight. That will actually weaken the copper. You just want a nice twist on it, and the wire nut's going to do the rest of the work for you to make a nice tight splice. And here I'm just wiring in the main cord that's going to feed that box. It's going to get plugged into the receptacle above. Putting a strain relief on that. Strain relief's important in case somebody pulls on that cable. It won't rip out of the box. But you don't want to make that strain relief too tight, just snug enough. And now I'm wiring up a receptacle that's going to feed the transformer for the makeup pump. And that's just going to get tied into the box that you just watched me wire up a few minutes ago. It's going to run off the same circuit. Now that the boiler and all the auxiliary pieces of equipment are wired up, now it's safe to tie in the feed at the panel. So I'm coming into the box up above and then dropping it down into one of those pieces of 2-inch PVC. I'm staying on the left side of the panel because the breaker that I'm going to use is on the left side of the panel. Now that panel is energized, so I have to be careful how I'm working in it. I keep all the tools out of my hands. I make sure the wires are clear inside. And now I'm putting tie wraps on there, but I only put enough tie wraps to keep it neat. I don't load it up with tie wraps and I don't put them too tight because you always want to be able to move the wire so you can trace them if you need to troubleshoot or identify wires later on. And the neutrals, just land in the neutral in the next available spot. The grounds are already terminated. And then I'm just landing my wire on the breaker. Give it a little bit of shape in the panel. Now I leave a little extra because if I want to move those breakers around later on for whatever reason, if I need to squeeze a 2-pole breaker or a 3-pole breaker in that location, I have the opportunity to move that. Okay, now very important, before I energize, what I'm going to do is test it. That'll tell you if you have continuity, and what I'm checking right now is to see if any of my hot legs are grounded, so I don't get any surprises when I throw the breaker on. And I shouldn't get any reading. The breaker's in the off position. Okay, that's good. Turn your head. Okay, got voltage going out. And this is kind of the finished look of the boiler. We have the circuits run and labeled. This is the circuit for the boiler. This is the Wi-Fi, so you can control the boiler remotely by phone. This is the surge suppressor. That'll take any shock to the system, any spike. And then that's the feed for the Wi-Fi. This feeds the whole boiler system, so in the event of a power outage, we can plug this into a generator and get the boiler back online. So this feeds this box, and then this is for the condenser pump, and then these two wires, one feeds the boiler and one feeds an outlet over on the other side that stays hot all the time, and I'll show you that. This is the outlet that stays hot, and that feeds this recovery reservoir. Keeps a little light, keeps pressure on it in the system, so if the system needs any glycol, it'll pull right from here and feed into the system. And then the only thing left is to tie in these sensors. I'll do that tomorrow morning. They mount to the supply and return pipes, and then they wire into the take-out pump. Just wanted to show how I terminated this boiler. This is really a very nice, simple boiler. For as complex as it is, it's very easy to wire and work on. So this is how I terminated my wires. This is the feed coming in, and it goes to 40, but it says L, G, and N. That's line, ground, and neutral. And then this is for the circulator pump. And when I brought it up, the red wire is a spare. That's the type of wire I had. I had 12.3 instead of 12.2, so I just safed off the red. And I leave this little service loop just to make it easier to terminate, because this is solid wire. And also, if it gets nicked or anything, I have a little bit of extra wire I can use. So that's it on that. So I just wanted to show real quick the sensors. That's the supply and return sensors mounted to the pipe that comes up and terminates into the bottom of the circulator pump. The supply and return, it's a smart circulator pump. It's going to regulate its own speed depending on the temperature that it senses on the supply and the return. It can pick up the speed a little bit or slow it down. And what I'm showing here is the terminating block that the wire goes onto. And 9 times out of 10, that block will just slip right off, and it's keyed in. It can only go in one direction. So you pull that down, you terminate your wires, and then you can insert it back up in there. It's a much easier way to work on it. Here I'm showing the external temperature sensor. I drilled a hole in the wall, lined up with my pipe inside. Just safing that off. What I had done was strip a piece of MC cable. I stripped the wire out of it, and I pulled my low voltage wire in that just to protect it from any mice or any kind of damage, insect damage. It's a real simple, just 2-wire installation on the temperature sensor. The outdoor temperature sensor comes in on this BX cable. I routed it around here, stayed clear of the valves strapped tight to the wall, and then I tie wrapped off to the black pipe going in. Just came in the back, and I tie wrapped off to something substantial. This post is pretty solid, so I just gave a little tie wrap on that. There's no provisions to bring BX in, but I put it in BX so that the mice don't chew on it out in the barn. Now I'm going to terminate. I terminate to the plug first, and then route it in, and then it goes down into that location right there. All right, that's all on this video. Thanks for following along. You can put any questions in the comment section and follow me daily for tips and tricks on Instagram.